Good morning. Today's class is about periodontal ligament. Coming on to the contents, we can see the definition, structure, cellular and extracellular elements, PDL fibers, blood supply, nerve supply, PDL functions, and conclusion. Periodontal ligament is composed of a complex vascular and highly cellular connective tissue that surrounds the tooth root and connects it to the inner wall of the alveolar bone. It is also called, that is moved on, the compostes, the pericementum, alveolar dental ligament, and a periodontal membrane. The structure of the periodontal ligament is the average width ranges from 0.15 to 0.21 millimeter, and the narrowest area is at the mid-root or region of the tooth where it acts as a fulcrum, and the region of the alveolar crest is the widest area, followed by the apical region. The width is generally reduced in a non-functional teeth and in an unerupted teeth, while the width is increased in teeth subjected to occlusal stress within the physiologic limits and in a deciduous teeth. The periodontal ligament is composed of cellular and extracellular components. The cellular components are the synthetic cells, that is the osteoblasts, fibroblasts, cementoblasts, the resorptive cells, osteoclasts, fibroblasts, cementoblasts, and the progenitor cells. The epithelial cell rests of Malassez, the defense cells which gain more importance during the inflammatory periodontal disease conditions, which are the mast cells, macrophages, neutrophils, lymphocytes and eosinophils, and cells associated with the neurovascular bundle. Coming to the fibroblasts, these are the major cell components in the periodontal ligament. They appear as ovoid or elongated cells oriented along the principal fibers, exhibiting pseudopodial-like processes, which synthesize collagen, and they even phagocytose the old collagen by hydrolysis. They synthesize collagen fibers, oxytocin fibers, reticulin fibers, and elastin fibers. The resorptive cells are the osteoclasts, which are the large multinucleated cells that resorb the bone. The characteristic features of osteoclasts are the plasma membrane of the cell lying adjacent to the bone that has been actively undergoing resorption and has a raised characteristic pose called as the ruffled or the striated border. The cementoclasts, which resorb, the cementum resorption occurs only in certain circumstances, and in such instances, the cementoclasts are located in the horseshaped lacrimae. The epithelial rests of Malassez, or these cells were first described by Malassez in 1885, and the remnants of Hertwig's epithelial root sheets which occur during the root development. They are distributed throughout the periodontal ligament and the cementum in the apical and the cervical areas, and they diminish in the number with age by regenerating and disappearing. They are calcified to form the cementicles. The epithelial rests contain keratinocyte growth factor and are positive to tyrosine kinase activities. When stimulated, they proliferate and participate in the formation of periapical cysts and lateral root cysts. The cementicles, coming on to the cementicles. The calcified masses found in the periodontal ligament, which are adherent to or detached from the root surfaces, are the cementicles, and they develop from calcified epithelial rests around the small spicules of cementum or the alveolar bone, which are traumatically displaced into the periodontal ligament from calcified Sharpey's fibers and from calcified thrombosed vessels within the PDA. We have the defense cells, which are the mast cells, which release heparin and histamine. Histamine plays a major role in inflammatory reactions, and the macrophages are capable of phagocytosis. The extracellular components are the ground substances and the fibers, which have the principal fibers and the secondary fibers. The extracellular substances are the space between the cells. The fibers in the periodontal ligament space is occupied by the ground substance, and it is composed of glycosaminoglycans like hyaluronic acid, proteoglycans, glycoproteins like fibronectin and laminin, and 70% of water. The proteoglycans function for cell-to-cell adhesion, cell matrix interaction. They bind the various growth factors on the core receptors and cell repair. The periodontal fibers, we have the principal fibers, that is the terminal portion of the principal fibers are inserted into the cementum and bone, which are termed as the Sharpey's fibers, and they are associated with abundant non-collagenous protein typically found in bone like osteopontin and bone cyber protein. Collagen is the important component of the principal fibers, and it is a protein composed of amino acids lysine, proline, hydroxychlorine, and hydroxylysine. Fibroblasts, chondroblasts, osteoblasts, odontoblasts, and other cells synthesize collagen. The principal fibers contain type 1 collagen. Coming on to the principal fibers, we have the transeptal fibers, alveolar crestal fiber group, and horizontal group, oblique group, apical group, and the interradicular group. The transeptal group, they extend interproximally over alveolar bone crest and are embedded in the cementum of the adjacent tooth, and they are reconstructed even after the restriction of alveolar bone, considered as belonging to gingiva as they do not have osseous attachment. Coming on to the alveolar crest group, they extend obliquely from the cementum just beneath the junctional epithelium to the alveolar crest. They function to prevent the extrusion of the tooth and resist lateral tooth movement. Coming on to the horizontal group, they extend at right angles to the long axis of the tooth from the cementum to the alveolar bone. An oblique group are the largest groups of the periodontal ligament which extend from the cementum in a coronal direction obliquely to the bone. They function in resisting the vertical maxillary stresses and transform them into tension to the alveolar bone. Coming on to the apical group, the apical group fibers radiate in a rather irregular manner from the cementum to the bone at the apical region of the socket, and they do not occur on incompletely formed roots. The interradicular groups, they fan out from the cementum to the tooth in the furcation of the middle multi-rooted tooth. So, as we can see, we have the transeptal group, alveolar crestal group, horizontal group, oblique group, apical group, and the interradicular group of fibers. Coming on to the secondary fibers, although periodontal ligament does not contain mature elastin, two immature forms are formed, that is oxytalin and eulanin. The oxytalin fibers run parallel to the root surface in a vertical direction and bend to attach to the cementum in the cervical third of the root. They are found throughout to regulate the vascular flow. Coming on to the blood supply and the nerve supply of periodontal ligament, the arterial supply of PDL is derived from three sources, that is branches from the gingival vessels, branches from intra-alveolar vessels, and these branches run horizontally and they constitute the main blood supply, and branches from the apical vessels that supply the dental pulp. Coming on to the nerve supply, they are either from the inferior or the superior dental nerves. The bundles of nerve fibers run from the apical region of the root towards the gingival margin. The nerves enter the ligament horizontally through multiple foramina in the bone. The small nerve fibers are used for pain sensation, and the larger nerve fibers are the mechanoreceptors which sense the touch and pressure impulses. Coming on to the function of periodontal ligament, they are categorized into physical function, formative and remodeling function, nutritive function, and sensory function. Physical function is that the soft tissue casing to protect the vessels and nerves from injury by mechanical forces, transmission of occlusal forces to the bone, attachment of the teeth to the bone, maintenance of the gingival tissues in their proper relationship to the teeth, and resistance to the impact of occlusal forces, that is as shock absorption. The theories pertaining to the mechanism of tooth support are the tensional theory. It states that the principal fibers of the ligament are the major factor in supporting the tooth and transmitting the forces to the bone. When a force is applied, the principal fibers first unfold and straighten and then transmit the forces to the alveolar bone, causing an elastic deformation of the socket. Finally, when the alveolar bone has reached its limit, the load is transmitted to the basal bone. Many investigators find this theory insufficient to explain the available experimental evidences. Coming on to the viscoelastic system theory, it states that the displacement of tooth is largely controlled by fluid movements with fibers having only a secondary load. When forces are transmitted to the tooth, the extracellular fluids passes from the periodontal ligament into the marrow spaces of the bone through foramina and cribriform plate. After displacement of fluid, bundle fibers absorb shock and tighten and the blood vessels tenuse. The arterial back pressure causes ballooning of the vessels and tissue replenishes with fluid. The formative and remodeling functions, the cells of the periodontal ligament has the capacity to control the synthesis and resorption of cementum and bone. Old cells and fibers are broken down and replaced by new ones. The periodontal ligament is constantly undergoing remodeling, and the variations in the cellular enzyme activity are correlated with the remodeling processes. The Autographic studies indicate a high turnover rate of collagen in the periodontal ligament. The rate of collagen synthesis is twice as fast as that in the gingiva and 4 times as that in the skin. A rapid turnover of sulfated glycosaminoglycans in the cells and amorphous ground substance of the periodontal ligament also occurs. The nutritional functions are the periodontal ligament supplies nutrition to the cementum, bone and gingiva by way of the blood vessels and also provide lymphatic drainage. In relation to other ligaments and tendons, the periodontal ligament is highly vascularized tissue. Coming on to the sensory function, PDL has nerve fibers that transmit sensations of touch, pain, pressure to higher centers. Free nerve endings carry pain sensation. Ruffini-like mechanoreceptors are located in the apical area and Meissner's corpuscles are the mechanoreceptors in mid-root region. Spindle-like pressure and vibration endings are located mainly in the apical region. Regulation of the periodontal ligament width. One of the most interesting features of periodontal ligament is its adaptability to the rapidly changing applied force and its capacity to maintain its width at constant dimension throughout its lifetime. These are important measures of periodontal ligament homeostasis. Coming on to the conclusion, thus in short, periodontal ligament is considered as an important root supporting structure of the periodontium. Since it is a soft tissue providing continuity between two mineralized connective tissues, the term periodontal ligament appears to be more appropriate. Thank you.